I mean, in just the last few years, AI has taken this absolutely massive leap forward. We have models like ChatGPT that can write code, they can summarize articles, they can even create art. So you gotta wonder, what was the one big idea that made all of this possible? Well, it turns out it was all about teaching machines a skill that's incredibly human: how to pay attention.
Okay, so here's how we're going to break this down. First, we're going to look at a huge problem that was holding AI back for years, this thing called the memory bottleneck. Then we'll see how the solution came from a surprisingly simple human analogy, which led to the model being able to literally look back at what it was reading. After that, things get really interesting when the model learns to turn that attention on itself. And finally, we'll see how that one idea lit the fuse for the entire modern AI revolution.
All right, so let's set the scene. Our story really starts with this fundamental hurdle for early AI, especially when it came to machine translation. And the whole problem really was about memory. Just think about it for a second. To properly translate a sentence, a machine can't just swap words. No way. It has to understand grammar, nuance, and how words that are far apart still relate to each other. For the early models, the longer and more complex the sentence got, the harder this became. Until, eventually, it was basically impossible. So the first big crack at solving this used a pretty clever setup called a sequence-to-sequence model, or seq-to-seq for short. It's simple, really. You've got two parts. There's an encoder, which reads the input sentence, let's say in English, and then there's a decoder, which takes what the encoder learned and tries to write the output sentence in, say, French. But, and this is the big but, here's how it worked. The encoder would read the entire sentence from beginning to end, and then it had to cram everything, all the meaning, the grammar, the whole shebang, into one single fixed-size package of information. This was called the context vector. The poor decoder then had to try and build the entire translation using only that one little compressed summary. And, the researchers who finally cracked this problem, they put it perfectly. They said this method squashes all the information. It's like trying to summarize an entire epic novel in just a single tweet. You're going to lose a ton of detail, right? Well, for the AI, this context vector became this massive bottleneck. It just couldn't remember enough to handle anything long or complicated. So, how'd they fix it? Well, the answer wasn't some crazy new math equation. Nope. It came from just watching how we, as humans, do this exact same thing.
I mean, of course not, right? Can you imagine? A real person doesn't just inhale a whole paragraph, close their eyes, hold it all perfectly in their head, and then just write out a flawless translation? The real process is way more interactive.
No, what a human translator actually does is start translating, bit by bit, and as they're writing each new word, they are constantly glancing back at the original text, focusing their attention on just the specific words that are relevant for what they're writing at that exact moment. And that right there, that act of selectively glancing back, that was the light bulb moment.
So this insight gave birth to a huge breakthrough back in 2014. It was called the bottleneck attention mechanism, and it was designed to give the AI that very same ability to look back. And this was a total game changer. Instead of forcing all that information through one tiny little straw, the encoder now basically opens up a wide-open highway of information to the decoder. It gives the decoder access to what it learned from every single word in the original sentence all at once. So check this out. For every single word the decoder wants to write, it now does this three-step dance. First, it gets to peek at all the info from the input. Then, a little part of its brain asks, okay, of all these original words, which ones are most important for the word I'm about to write right now? And finally, it builds a special, custom-made context vector just for that one step, focusing only on the most relevant stuff. It's literally paying attention.
And this visual, it just shows you how powerful this is. When the AI is translating a phrase where the words get flipped around in the new language, you can see it correctly focusing on the right words in the source text, even though they're in a different order. It wasn't just matching words anymore. It was actually learning the grammar and structure. This was a huge leap.
But this amazing idea was really just the beginning. It wasn't long before researchers started asking a new question. If a model can pay attention to an input sentence, what happens if we turn this powerful new tool inward? What if a model could pay attention to itself?
And that was the next million-dollar question. Let's forget about translation for a minute. Could you use this same mechanism to help a model truly understand all the complex connections inside a single sentence? And that's how we got this idea called self-attention. It's basically a way for the model to look at every word in a sentence
And for each word, figure out which other words in that same sentence are the most important for understanding its meaning and context. It's letting a sentence analyze itself.
Okay, look at the sentence. When it says, because it was too tired, self-attention allows the model to figure out that the word it is talking about the animal. It basically draws a big bright line connecting it and animal.
But, and this is the really cool part, watch what happens when we change just one word. Now it says the street was too wide. Using self-attention, the model instantly gets that the context has completely changed, and that same little word it is now pointing to the street. That right there, understanding context and ambiguity like that, that's a superpower for an AI.
So now we have this incredible new tool, self-attention, and it's set the stage for the main event, the moment that truly kicked off the AI revolution that we are all living in right now.
In 2017, a paper drops with what has to be one of the best, most epic titles in all of computer science. Attention is all you need, and the idea inside was just as radical as the title.
This paper gave us the transformer. And the big idea was, let's throw out everything else, all those old, slow, sequential parts, and build an architecture using only self-attention. The old models had to read a sentence word by agonizing word, which made them slow and really hard to scale up. But transformers could look at all the words at the same time, in parallel. This was a lightning-fast approach. Suddenly you could train models that were way bigger than ever before. The floodgates were officially open.
I mean, just look at how fast everything happened after that. You go from fixing that translation problem in 2014, to exploring self-attention in 2016, to the birth of the transformer in 2017. And from there, boom, the transformer became the fundamental blueprint for basically every single major AI model you've ever heard of.
So the next time you ask an AI to write an email for you, or debug some code, or explain a tricky concept, just remember, all that magic, its incredible power, it all traces back to this one beautifully simple and very human idea, just teaching a machine how to pay attention.
Attention really did change everything. It was the breakthrough that defined this whole era of AI. So it really makes you wonder, right? What seemingly simple idea is out there right now, just waiting to become the next great leap forward?